Okay, so now we're going to carry on from where we were. We finished up. We got our program running. No errors. We have our view here. We've got our diagram window set up. And now let's go ahead and do a parametric table. So we can produce this curve here. Actually, let's do the required NPSH curve first. So what we need to do is we need to have an NPSH R as a variable, or we won't be able to set up the table. So NPSH R, and this is going to be English equals, and I'm going to copy and paste it in. I'm going to show you how I did it, but then I'm going to copy and paste in a table and produce this equation, which follows that curve fairly closely. So 3.55 feet, etc., etc., etc. What we want to do now is create a parametric table. So if I didn't have a value here, I could just put NPSH R English or whatever I want equals 1 or any number, just to give me a value for it that wouldn't cause it to choke on it. So what we want to do is we're going to create an 8-row table, and we're going to have NPSH R English, and we're also going to have V dot English. There we go. And actually I want those reversed order, so we go V dot English, NPSH R English, click OK. So I've got that, and what I did was I went and I looked at this pump curve and took data points at every 100 GPM from 1 to 800. So we're going to say gallons per minute. First value is 100. Last value is 800. It's increasing linearly. And click OK. Fills that in for us. And then we're not doing any calculation. This is just, we could do this as a lookup table, but that's a whole separate topic. So we can put it in here. It's not going to be an issue. And we will put in the values. So I went over, I copied them, I pasted in here, and we're going to make this properties, units are going to be feet. Okay, so now I can make a plot of this. So I can say table, I'm going to curve fit the data table, and I want Y to be our NPSH, X to be our V dot, and we'll go with a polynomial, third order, seemed to work okay, and we'll do a plot data. I think that'll do it. What's the curve fit? Now let's do plot data. Plot data, and what do we want to do here? All right, let's see. So we plotted the data. Nice curve there. Let's see if we can put in some, maybe a line would be nice. Make the line a nice little fat line. There we go. It shows up in the background. And we want cubic spline so it makes a nice smooth curve. And that should be good. Now we want to, actually so to get this equation, probably jumped a little bit because I was doing a couple of things before I came back to this. We needed to, when we did this, plot under the tables. We can curve fit the table data, or we can just, from within the plot, we can curve fit the plot. Under plots, curve fit. But let's go ahead and do it. Curve fit table data. And what we needed to do was, we've got those, we went to a third order, and then we wanted to fit the data. So this is the formula. So what we want to do is copy that. Okay. And say done. We also had the option to plot it, which we did here. We can change these if we want. So that's going to be NPSH. And we'll just leave it at NPSH because we're going to overlay a plot on top of it. And okay, and this is flow in gallons per minute. Okay, we can move things around if we like. And let's go ahead and change this scale range up to 40. And make it in 5 increments of 5. And minimum of 0. Okay, so there is our, and let's make it from 0 to 100, 0 up to, actually up to, say, 1,000, intervals of 100. Click OK. 1,000. There we go. So there's our NPSH curve on there. And we can rename that, call that NPSH curves. We'll overlay on top of that. So the next thing we need to do is, so the value that we copied it, we didn't paste it in yet, but it'll paste in y equals, so y is NPSHR. I think at one point I rounded this off to 3.5 feet, and then I left the rest of them in, but it's feet. You have to put your units in though. So this many feet per GPM, this many feet per GPM squared, and e dot n squared, right? X squared, so times, so feet per GPM times the flow rate, feet per GPM squared times the flow rate squared, feet per GPM cubed times the flow rate cubed. So you have to make that. You have to substitute in flow rate here and units after the number, or it won't properly. All right, so everything else looks, it's a little bit different. I think it was an older version that had a different rounding parameter, but it's close enough, so we're going to use that. But that's how you get that number, and then you will have to edit it so that it fits your parameters that you're using. So now we've got NPSHR, and what else do we want to do? So we want to make a parametric table for 25 and 60. If we look over here, we've got 25 and 60, and we can do another one if we want. I might make that part of the assignment. So let's do 25. All right, so what we want to do is we're going to change the flow rate and maintain a constant temperature. So we can say temperature is 25, but we might want to change that. So we'll put that up here just so we can put a, if not, parametric table. And we're going to put in V dot also, and end if. Okay, so let's make a new parametric table. Where's my new parametric table? Oh, right there. New parametric table. So this will be, we'll leave it table 2 for now. And we're going to go back to 8. We're going to have T, because at some point we're going to want to change the T, and V dot eng. Okay. And then what do we want coming out? We want NPSH available English. Okay. So temperature, we're going to keep it 25. So we click on this black triangle. Again, we can say first value 25, last value 25. Click OK. We're good. For the flow rate, we're going to go from 100 to 800 again. 100, 800 gallons per minute. Okay. And now we should be able to solve it. And we did. Okay. So now what we might want to do is overlay. I notice at 800 we're going significantly negative, so obviously that's not going to work. But we can overlay the plot. So we can say, all right, we want to overlay plot. So up here we have that's property plot. New overlay. So we're going to overlay on top of the NPSH curves plot. We want V dot English. That's our gallons per minute. We want that on the x-axis. That's good. And we want NPSHA English on the y. And we're going from, that's all locked in. Spline fit, that makes a nice smooth curve. Automatic update, so if we change anything, right here we have rows 1 through 8, that's fine. When we change the temperature, we'll change that. So we'll make a fat line again, come on down to this guy. We don't need markers, and we'll make this red. Show plot. grid lines, click OK, and there we go. So notice it crosses right around 600 gallons per minute, 700, 800 negative. They drop below the 0 point, that's fine. They don't show up, we don't care. We could make them show up, we could make this show the negative numbers down as far as it goes, but we don't need to, we don't want to. So now what we can do is we can say, add some text and say 25C, or actually we can even use, I think we have the degree symbol down here somewhere. Yeah, so we can say degrees C, and the color is red, so we'll match it to, and we'll make it bold so it stands out. Okay, so that's our 25 degree C curve. Now what we'll do is we'll do another, we'll update our parametric window, and we'll add 60 degrees, and I'll show you how to do that. So we want to, we're just going to edit the parametric table. So we're editing the table 2. We're going to add more runs, insert runs, and we want, well, we went negative after 6 here, so we're going to go negative before that for this next one. So we'll say we'll add 6 after run 8. Okay. Now what we want to do is go from run 9 to 14. We'll make it 60 degrees. Okay. And we're going to go 100 to 600. 100 to 600. Make sure you change this up here to 9 to 14. And OK. Calculate. Brings it down to 1. So we could have gone to 7. It would have been slightly above, looks like. Well, let's go ahead and overlay plot. Oh, we can add that in. We'll just add another row. Insert row. Run. After 15, we're going to add 1. 14, we're going to add 1. That's going to be 15. We want this to be 60, 700, and calculate. And now we're going to the negative side. Okay. So let's look at that plot. So let's add that plot, overlay plot. Back up here, overlay plot. The most important thing to remember is, so we still want NPSH A, but we don't want all of these runs. We only want 9 through 15. So we select that. Automatic update. It should be spline fit. Sometimes it doesn't show up for some reason. It might just be when you're doing partial runs. Fat line, green is fine. So we've got that. We do not want it. So for a system diagram where we're going like 1, 2, 3, 4, 5, and then back over, you want to connect the last point. Here we don't. So we go OK. And notice it's a little jerky. Now we can make it a cubic spline. It'll smooth it out. And we can put in text. Call it 60. Click and hold. Pull the degree symbol out. C. And we're good. Oh, we want green color to match. So we'll call that green color. Click OK, OK. drag it down to here. And then we could go either lower temperature or higher temperature and carry on. So that's 20 minutes. I'm going to leave it at that for now and go on to the next video. So this is video 2.